Hello and welcome to your 6th lesson on functions and relations. In this lesson, we're going to look at the inverses. So we're going to start here with A and B, okay? So this is my domain and range, this is my domain or my x values, this is my range or my y values. In other words, this is my input, this is my output. So here it's saying my input is half of my output, okay? Or my x values are half of my y values, all right? Now let's take a look at the inverse. The inverse would be, now your B becomes your input and your A becomes your output. All right? So here it's saying my B values are double my A values. Okay? Now let's take a look here at number 2. Here we have my A values are the square roots of my V values. So my input is the square root of my output. So my X are the square roots of my Y's. Okay, or my y's are squared, my x is squared. If I square this, I get that. Okay, now let's take a look at this way. My input is the square of my output. The input is the square of my output. Let's take a look at that. So, therefore, I have to square root this to get that. If I look at this here, each one of these is mapped 1 to 1, 1 to 1. Okay? This one, well, I could have two x's with the same y. Okay? Two x's with the same y. This one here, we have 2y. Every x, some x's have two y's. So now I'm looking at this. In case 1, the inverse is a function. In case 2, the inverse is not a function. Why? Well, this here, the original, this is a function. This is not a function. Why is that? Well, think of it this way. A function is your input can have, each input could have an output, okay? These guys here, my inputs could share an output. But in this case here, my output cannot share an input. These guys can't have two. Think of it this way. In some cultures, males are allowed marrying more than one female. Females cannot marry more than one male. So this is allowed, okay? Here, this male has two females that go to him, okay? Now here, this female has two males that go to him. That's not allowed, okay? So think of it that way. So if you have a male, two males going to the same female, that's not allowed at all. All right? But we could have two females going and marrying the same male. Hopefully that makes sense. All right. So let's go over this here. It says, consider the operation of putting your socks on and then putting your shoes on. What would be the inverse operation? So that would be going in the exact opposite. Would be, instead of putting on your socks and then putting on your shoes, would be going opposite. So that would be taking off your shoes, off your shoes, then taking off your socks. Okay? So it's in the opposite direction. So we're doing the things in opposite order, and we're doing the opposite of what we were doing. Okay? That is technically my inverse operation. Let's take a look at example number 2. It says, complete the table to describe the inverse of the function. Okay? So multiply by 2. Well, that would be divide by 2. Next one says square. Well, that would be square root. Okay? Is this a function inverse? Yes. Is this a function the inverse? No. Okay? Because not everything maps out perfectly. Now, so let's try the next one. Take the reciprocal. So take the reciprocal would be take the reciprocal. Is now reciprocal. So is this inverse a function? Yes, because 1 will only be to 1. The next one is divide by 3 and then add 1. So this would be, first we do the second one. So subtract 1. Then divide by 3. Oh, sorry, then multiply by 3. Oopsie. Then multiply by 3. And this is yes. Okay? So basically, it's only when we kind of square root or something where we get an inverse. Okay? All right, so let's continue this on example number 3. It says, consider the function defined by the following ordered pairs. So these are my ordered pairs. Describe the inverse of the function in a set of ordered pairs. So the inverse would be switching my x and y's. So my inverse is switching the x and the y. So that's going to be negative 2, comma, negative 4 is 1. Next one is going to be negative 1, comma, negative 2. Then we're going to have 0, comma, negative 1. Then 1, comma, 0. Then 2, comma, 4. Then 3, or 8, comma, 3. So I just switch my x and y values. Okay, so graph the original function. So I'm going to have to graph the original function here, which is negative 4, 2, negative 4, oops, negative 4, and then up 2, up, down, negative 2. And then we have negative 2, negative 1, so negative 2, and then negative 1. Then we have negative 1, comma, 0, so negative 1, comma, 0. Oh, I think I'm starting to see a little bit. Okay, then we have 0, comma, 1, so 0 and 1. Then we're going to have 2, comma, 4, so we go over to 2, go all the way up to 4. All right, and then the next one is 3 and 8, so we go 3, and this is all the way to 8, so it looks like that. Now I'm going to do in pen my inverses. So we want to now graph my inverse. So we're going to have negative 2 and then negative 4. And then we have negative 2, or sorry, negative 1 and negative 2. And my next one is going to be here. And then it's going to be there. And then this one here is going to be, sorry, I'm at 2 and 4, so 2 over, and then 4, or sorry, 4. This should be 4, comma, 2. I made a mistake there, so 4 over, and then 2 up. And then my next one is going to be 8 over, and then 3 up, which is right there. So if I look at this, and I want to find my reflection, how do I do that? I'm just going to find my line of reflection. Now my line of reflection is going to be something very neat. That. My line of reflection is along the line y is equal to x. Okay? So state the equation of the mirror line. It's y is equal to x. And that is it. All right. Let's take a look now at number 4. It says, sketch the graph of the inverse of the function defined by the following graphs. So we want the inverse. Okay? So I'm going to have to reflect this all along this line here. So y is equal to x. Right? Now basically I change my x and y points. So this point here, which is negative, well, I think we counted by 2s, 2, 4, 6. Negative 6, comma, 0 is going to be 0, comma, negative 6. So we go 0, 1, 2, 3. So I'm going to call this 0, comma, negative 6, which is right there. So this is now 1 point. So this point moved there. Now my next point, we have this, is going to be over here. Okay, because this is 0, comma, 6. Negative 6, that comes negative 6, comma, 0. And this last point, which is 6, comma, whoopsie, this is negative. This is negative 6, comma, 0, so 0, comma, 6. So these 2 points just switch. The last point right here, which is 6, comma, 0, becomes 0, comma, 6, which is up there. So my new graph is going to look like this. Okay? So it looks kind of like this here. I'll put it in pen, and it goes forever that way. I'll put it in pen so we can see. Okay? So that there is my new graph. Hopefully you see that. It's not very clear. Now let's take a look at the next one. I have these points. So this point here becomes, looks like negative 6 comma 0. So we go negative 0, 0 comma negative 6. That's this point. This next point here, which is my loop, becomes, we look, negative 4, so that goes there. So we kind of loop to this. And then this next point is going to just move up here. So my new graph looks like that. Okay, because this is 6 comma 0, so it's going to be 0 comma 6, which is up there. So that is that graph. All right, let's take a look here. Now at number 5, it says, consider the following equation. Find an equation of the form y is equal to mx for the inverse of the function. So we're going to follow this step by step. We know y is equal to 3x plus 2. Step 1 is we're switching x and y. Okay? So the inverse, we switch x and y. So x is equal to 3y plus 2. That's going to be my step 1. Step 2 is, now we want to solve for y. So we're going to subtract 2 from both sides. So I get x minus 2 is equal to 3y. I have to divide everything by 3. So I'm going to end up getting y is equal to x minus 2 divided by 3. Okay? Now it says, next part says, graph the original and its inverse. So the first one, well, the first one here I'm going to do in pencil. We have plus 2. And my rise is 3y, so every time I go over 1, I must go up 3. Okay? So here, every time I go down 1, 3. So it's like that. So my graph is going to look something like this for this one. And now my next one is, this is the same as 1 over 3x minus 2 over 3. So my intercept is 2/3. So negative 2 over 3, which is going to be somewhere there. And every time I go over 1, I go up 1/3. So every time I go over 3, I go up 1. So go over 3, go up 1. It's going to look something like that. And this graph here is going to look like this. Somewhat. Okay? So they're going to look like that. Okay? So there's both of my graphs. This one is y is equal to negative, is equal to 1/3 x minus 2 over 3. And this one here is y is equal to x plus 2. 3x plus 2. All right? Now, it says graph the original in the grid. Is the inverse of the function of the equation also a function? For this case, yes, it is a function because it is perfect. Remember the straight line test? We can also do that for graphing to see if it is a function. All right, now this next part here kind of explains to you how we do this on the graphing calculator. Okay, so how to find the TI on a TI-83, the inverses. Okay, so hopefully you studied that, and we're going to go over and try and do this ourselves. So get your trusted graphing calculator, and we know we're going to look at question 4a, and the original here it says is y is equal to that, right? So y is equal to the absolute value of x subtract 3. So let's put that into my calculator. I want to go on, clear, y equals, and we want the absolute value, so it's like in math, go into math, number absolute, and we have x, and we want to subtract 3. Graph. Look at that. That looks very similar to this here, the original. Okay? Now, we want to find the inverse of it. So what do I have to do? Well, let's follow the steps here. First, we're going to push second. Then we're going to go into our program. Oops. So we'll go second, and we're going to go program. Now, in our program, we want to go all the way down, and we want to go to the draw inverse. Draw inverse, which is number 8 on mine. Okay, we're going to push enter. All right, now we want to put in my y equals for the inverse. So we're going to put variables, we're going to go y, and then we want our function y1, enter. And now I'm going to push enter again. And there is my inverse function right there on the graph. And that's exactly what we looked like, okay? Now, let's try and do this, and we get the exact original graph of what we saw earlier, which is very nice. So the graph is confirmed. I look at this, and I look at that. They are the same graphs. They are more or less confirmed. Hopefully you understood this, and good luck as I see you tomorrow, and hopefully you have many questions to ask me. Come up with some kind of intriguing question to make me think about this stuff even more tomorrow. See you tomorrow.